And it is my great honor to have a chance to talk about the title, How Advancement in ICT Changes Traditional Behavior Patterns in Transport. There is no question that the ICT revolution is rapidly changing our daily life and gives us challenges and opportunities to resolve severe transportation problems such as traffic congestions, accidents, and air pollution that we have faced. In this presentation, I'm going to focus on the way that how to resolve those transportation problems and eventually improve people's happiness and welfare by utilizing the integration of ICT and transport technology. In the last part of my presentation, I'm going to introduce various cases that we have done or under research to achieve smart, eco-safe welfare and low-G mobilities in transportation systems by ICT convergence. Nowadays, there is a drastic increase in the worldwide smart connected devices market, such as tablet and smartphones. Especially in Korea, most people use smartphones anytime and anywhere in our daily life. And it is forecast that the smartphone market is going to be increased up to 25 million unit ships in 2017 in Korea. The ICT advancement converged with smarter devices, big data, cloud computing, social network, and so on is changing our daily lifestyle in all the social service sectors, including transport services, by enabling higher levels of information connectivity. Especially for the transport sector, the ICT advancement provides us various useful services such as receiving real-time road traffic information, bus arrival time, and even taxi safety services in returning home at nighttime. Also, when the ICT converged with transport technology, advanced and innovative transportation modes or services have been promoted, such as driverless vehicles, high-speed rails, or even flying cars. But the reality in current transportation situations in our daily life is somewhat different. There are many pending challenges to be resolved in transportation area. The first challenge to tackle is the issue of traffic accident. Among OECD member nations, Korea is the worst traffic safety country and ranked at the lowest in terms of traffic fatalities. So as you can see in the slide, more than 5,000 people are dead annually, which means that 15 people are dead every day, and 17,000 people are injured due to car crash. Also, the total cost of road accident in 2010 was 11.6 billion US dollars, which was 1.1% of GDP. There should be great opportunities to take into account of ICT convergence to reduce fatalities and casualties. The traffic congestions, especially during the peak hours, are getting worse, even though continuous social investment. The total cost of traffic congestions in 2009 was 26.5 billion US dollars, which was 2.8% of GDP. In this respect, we need to think about a different approach to overcome this problem, and I think one of the solutions is the integration of ICT and transport technology. Increased vehicle use has enabled us to enjoy fast and convenient travel, as well as rapid economic development and prosperity. But however, this caused serious negative effects such as air pollution and even climate changes. So recently, one of the key agenda of the world is to reduce greenhouse gas emissions. So this issue also could be resolved with ICT advancement. We have experienced lots of irrational traffic operation and management in our daily movement. For example, low standard of traffic signal control, such as too long signal cycle and non-adaptive control to traffic demand, causes signal violations and delays at intersections. Also, illegal driving and parking behavior are widespread, which can cause speed violation and illegal parking, and eventually impede people's happiness and inconvenience. So there should be some solutions to change this behavior and those problems by utilizing the ICT and the transport technologies. The public transportation, especially intercity public transport, has various limitations, such as the lack of intermodal linkage and user inconvenience due to independent fare policy and payment systems, in a sense that users pay travel fees each time they transfer from one mode to another without any transport discount. And also, demand response transport services might be very useful for the people who live especially in rural areas. However, under the current transportation systems, there isn't enough investment for vulnerable people. Then, what should we do? What kind of policy and strategy should be taken to resolve the current transportation situations? As I mentioned before, I think one of the great solutions is the integration of ICT and various transportation technologies supported by creative idea that could solve lots of pending threats and challenges in current transportation situations and improve system effectiveness and user convenience and social welfare. The future transportation based on ICT convergence should be pursued in a way that is consistent with smart mobility, which can ensure seamless and high-quality transport, as well as eco-mobility for clean and energy-saving transport. Also, it should be aimed at ensuring safe mobility for free of accident and fatalities, as well as welfare mobility for convenient and fair transport. And finally, logistic mobility for low logistics cost and low carbon transport. From this slide, I'm going to introduce the total 9 research topics based on ICT convergence that we have done, all under research to achieve the mentioned 5 mobilities in transportation systems. This is the mobile all transit. As you know, the provision of advanced information on public transportation can be a key factor affecting their choice of mode. However, when a traveler uses intra-regional public transport modes, especially for a long trip, it is very hard to schedule his itinerary since there is no such system which allows certain users to search optimal real-time transport information among different public transport modes and select a preferred itinerary through the entire trip. In addition, the fare payment system differs from mode to mode, causing inconvenience for users to pay travel fares each time they transfer from one mode to another. Hence, the mobile all transit aims to integrate intra-regional travel information as well as fare payment nationwide for different public transportation modes through a single mobile device. Mobile all transit can help assist travelers select convenient and optimal trip plan, short waiting times, lower fare by transfer discount through the entire trip. Recently, Seoul City has conducted pilot study to design 2 night bus routes for users who return to their home very late, around 1 to 2 a.m. In the decision making of route planning and dispatching, interval control of a night bus, they collected and analyzed mobile phone location data and residential addresses of these users, and it was a very successful case by integrating big data and its analysis methodology as well as the ICT and transport technologies. This is the case of demand responsive bus system. It is a user-oriented mode of public transport characterized by flexible routing and scheduling, and very useful to provide public transport service in areas of low passenger demand. This system was introduced in Korea, named as e-bus, and can be used by real-time or pre-reservation via internet or smartphone. The e-bus system provides flexible bus route and stops depending on demand of passengers who have same departure times, origins, or destinations. The cloud transport system, the CTS, is a sharing-based transport system that converges ICT with transport technology. This covers all inter and intra-regional transport modes, including metros, flights, railways, buses, cars, bikes, even electric vehicles. The CTS enables us to plan their optimal itinerary and transfer information based on sharing of different modes, including bikes, through the entire trip, and lower travel cost, increase efficiency, and establish more sustainable transport systems by shifting private car users to sharing mode. This is a case of public road control system by ICT car SOC convergence. Usually, the public roads are considered as open public facilities. However, public road reservation system in which drivers should make a reservation in advance for traveling on a road could be implemented to relieve not only traffic congestions but also greenhouse gas emissions in spite of some inconvenience to drivers by the system. As you can see in the second slide, the second figure shows a dynamic HOV lane control, which could be applicable to expressways in which HOV lane can be shared with regular cars based on traffic demand. Actually, the dynamic HOV lane control will be applied to Olympic lanes during the 2018 Pyeongchang Winter Olympic Games. Recently, a research project is underway to forecast future travel times based on real-time smartphone data with integration of ICT technology. In addition, this system provides traffic congestion map created with navigation data collected by mobile devices, which could be used for developing congestion index and managing congestion level on each roadway. A social curation system is based on information gathered and analyzed by various social networks and smartphones. Useful information based on traveling or moving experiences of a diverse population are collected and analyzed in a system to provide customized paths and route for each group of people. The research project will be launched very soon, maybe next month, to develop the social curation system for especially vulnerable people group. In a given current situation in Korea, where most of containers are transported via trucks, traffic isn't always good, and the vehicles emit a large volume of greenhouse emissions. The automated container transport system, AutoCon, is one of the solutions to overcome this situation, and innovative green logistics technology that would be able to transport containers on a track at a standard speed of 56 km per hour, connecting both cities such as Seoul to Busan. And also this is a safe and cost-effective and eco-friendly system. Next is the parking space management system for loading and unloading goods. Basically, this is based on the reservation system for loading and unloading goods to prevent hovering times of vehicles and reduce traffic congestion, especially in downtown area. This system could be deployed relatively easily with integration of ICT and smart connected devices. The conclusions. The ICT revolution is rapidly changing our daily life and gives us challenges and opportunities to resolve various transportation problems such as congestion and air pollution. Also, improve people's happiness and welfare with the integration of transport technology. Hence, with the integration of the ICT and transport technology, the new and innovative transportation systems which aims to achieve smart and eco and safe welfare and lodging mobility need to be developed. Also, the deregulations or removal of observed regulations should be followed simultaneously for successful accomplishment of innovative transportation systems in reality. Yeah, this is the end of my presentation. Thank you for your attention. Thank you.